Hi all, this is Mr. Yeager for chemistry. We are now looking at the next gas law, which is Lussacs Law. And we are going to get into, with this one, the pressure and temperature now being related with each other. And so pressure and temperature are directly related with each other. Okay, again, keeping volume constant. Mass is always constant. We're not messing with mass at all with these. So pressure and temperature are directly related. This is the best example with the compressed can in a fire, which would then explode because you're keeping it, the volume staying the same, but the pressure is building up, and then obviously it will release. That's very obviously violent reaction of it. So increased pressure, increased temperature, that is what we're looking at this time with Lussacs. Okay, we got a couple little pictures here where basically if I do increase the temperature, the particles are going to hit the walls more often, which that creates more pressure. Okay, so explosion of an automobile tire, if they're put up too high, or obviously that they shrink in the winter, that would be obviously the opposite example. The egg bottle trick is where you basically heat the bottle some and you change the pressure, which then makes it possible that you can suck the egg up the bottle or up the flask. All right, it's an interesting one there. All right, so our equation for it is P1 over T1 equals P2 over T2. This obviously looks very similar to Charles' law, at least the setup for it. But again, when they are directly related, we're putting them over each other because that will show that on the other side, if one goes up, the other one must go up to make sure we get the same quotient, the same amounts. Once again, temperature has to be changed into Kelvin. All right, and we need to make sure the pressure units do match, even though we shouldn't be messing with that too much. Okay, we'll see how much that happens. All right, again, this is finally where we will probably say you change these conditions to standard temperature and pressure, STP, because now you are changing both in some ways. So we need to pay attention that standard pressure, again, is 1 atm and standard temperature is 273 Kelvin. Lussacs Law, the graph, since it's directly related, it's very similar to volume and temperature. We got a straight line going up. Again, temperature goes up, pressure goes up. And here we go with some examples. So, what do we do here? We got a gas, it's cooled from 323 to 273. So we should see the pressure go down. It says what's the final pressure if the original pressure was 750 millimeters of mercury. So we're going to be able to keep it in millimeters of mercury. So our formula is P1 over T1 equals P2 over T2. So I'm going to do basically the same idea I did with Charles. I need to put the pressure on top, so I'm starting with 750 over 323 Kelvin. It's very nice that the problem is giving us Kelvin to start off with. That is 4 sig figs. So I need to keep that. And it's changing it to 273.15 Kelvin. I want the new pressure. I can do, again, cross multiply. I'm going to do 750 times 273.15 equals P2 times 323.0. I can then divide 323.0 over to the other side. Okay, so let me solve that. And we should get a new pressure of 634.2 millimeters of mercury. All right. I'll still do 2 more, even though it's very similar to what the gas law was with Charles. All right. Again, you're just going to have to pay attention to what's being given to you when we start mixing all of these up. All right. So for this one, it says a gas has a pressure of 0.37 atm at 50 degrees. What is the pressure at standard temperature? So we finally run into this. We're not at STP, but we're at standard temperature, so that's 0 Kelvin. That's 0 degrees Celsius, which is 273 Kelvin. Sorry, we don't go to absolute zero. All right, so I can set this up again. P1 over T1 equals P2 over T2. 0.370 over, I do need to change 50 degrees to Kelvin. So Kelvin equals 273 plus 50. That's 323. And then I am lowering that to 273. So I should see the pressure go down. So I'm going to do again the crisscross here. 323 P2 equals 0.370 over 270, or not, times 273. and then I'm going to divide 323 out. So 0.37 times 273 divided 323. I get a pressure of 0.31, well, just 31, because no, sorry, 313. Okay, ATM. There we are. Okay. All right, one more. Determine the final pressure when a constant volume of gas at 1.75 atm is heated from 20 to 30 degrees. Okay, yay, it says constant volume, so what? I'm going to plug this right on in. So I got 1.75 over 20 plus 273, so that's 293. And then I'm raising it to 30 plus 273, which is 303 P2. I get 1.75 times 303 equals 293 times P2, and I can solve. Oh, I screwed up there. 1.75 times 303 divided by 293. I get a P2 of 1. Well, I mean, I know the 20, 30 degrees kind of throws it off, so I guess I'll just do 2 ATM, 1.8 ATM. Okay. And there you go. That's how we do Gay-Lussacs law. Very similar to Charles' law, just changing pressure instead of volume now. And we will go from there. Thank you.